Section 10, Part 2, we will look at the regression line and equation. When graphing the regression line, the line should run through points. The distance from the line to each data point should be minimized, and if the line does not go through the points, something is wrong. Here is the regression equation. Notice it looks just like our old friend y equals mx plus b, slope-intercept form of a line. A probabilistic model. One variable is not determined completely by the other variable. X is the predictor variable and y hat is the response variable. B sub 0 and B sub 1 are sample statistics used to estimate population parameters, capital B sub 0 and capital B sub 1. For predicting the y value, we follow the guidelines listed here. For most linear correlation problems, we follow the following 6 steps. An example. We want to find a regression equation for the data given. So first, we plot the points to see if it gives a linear pattern. Now we use our calculator to find R. So we enter the data into L1 and L2. To get the R, we hit second stat on the calculator. Scroll to tests. Then go all the way to the bottom until you find linreg t-test. After hitting enter, scroll down to find R. Since R equals 0.890, we can see this is fairly close to 1. Now we do a hypothesis test to see if there is a linear correlation. Step 1, we label HO and HA. Step 2, we find the test statistic, which is R, and we know it's 0.890. Step 3, we find the critical values. Assume alpha is 0.05 here since we were not given it. Also, we need to make note that n equals 7 here so we can look at the table to find critical values. Looking at the table, we see that the critical values are plus or minus 0.754. Step 4, we reject null hypothesis since 0.890 is greater than 0.754. Step 5, there is sufficient evidence to support claim that there is a linear correlation. Now we find the regression line using the line y equals a plus bx as it looks on the calculator. We see that b equals 1.643 and a equals -1. So the regression equation is y equals -1 plus 1.643x. Now we draw the line on the scatter plot. Using extreme values is good practice here. So using x equals 2 and x equals 6. Now let's use our calculator to find the y values for x equals 2 and x equals 6. And we get 2.286 and 8.58 as our y values. Now we plot those points and connect the dots. Now we want to predict y when x equals 5. So plug it into the regression equation and evaluate. So when x equals 5, y hat, our predicted value, is 7.215.